Assalamu alaikum warahmatullah. Today we are going to study about what is the purpose of this section. In your previous study of chemistry, you have learned about the several terms at an introductory level. In this book, you will study them in the greater depth. So this topic is designed to revise some of the terms that you have studied before, that you have met before, and will meet again in more detail. You will study these things in more detail, okay? So here we are. What is the element? Element you should know that in the periodic table, okay? In the periodic table, let me make it clear that in the periodic table how many elements are there? There are 118 elements, 118, and out of these 118 elements, 92 elements are naturally found, and the rest are you can say they have been artificially prepared. So let me tell you that elements, what are the elements? Elements are the, you can say, basic members, okay, from which all the matter is made up of. The universe, the full universe is made up of these elements. These elements combine with some specific ratio to form the new things. So how would we define elements? Element, okay, elements are made up of same type of atoms, made of same types of atoms, okay, which we cannot decompose, which cannot be decomposed, which we can't decompose, cannot be decomposed, okay, by ordinary, means simple, by simple methods. Ordinary, instead of ordinary, write simple methods. So this is all about elements, okay? So here we can start. So it's clear if I say that we have elements, means here are some given. So you can say that these are the elements. For example, helium, this is the hydrogen, okay? Actually the element is, its name is hydrogen, Hydrogen, but it's difficult to write all this, so we represent it by a word, a capital word, that is called symbol, okay? So this is symbol for element. Hydrogen with H, lithium with Li, as you have seen, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So instead of writing their full names, here are their short, you can say, simple symbols, okay? If there are two words, then first is capital, like calcium, and other is some other. So you can see each box in the periodic table contains a, what is calling a capital letter, or more often a pair of letters, okay? What is there? A pair of letters. So the first is always capital, first letter, and the second one is never a capital letter. It cannot be capital, it cannot be capital, it cannot be capital. Each letter or pair of letters represents an element. You will know some of them from your everyday life. For example, oxygen is an element you breathe. When you breathe, so you take an oxygen, okay, that is in the molecular form like this, O2, okay? So, and iron is the element you use to bodies of cars and the bicycles. So iron, you should know its symbol. You would have studied in a Fe, okay? Fe, this is symbol for iron, okay? So iron, you know that it gets rust and it is used to make the bodies of cars and the bicycles, okay? You may have been taught that the element is a substance that contains atoms of only one type. As I have already told you, that it contains the elements of atoms of the one type. Surely it contains atoms of one type. So elements are chemically, what are elements are the? Elements are chemically the simplest substances, so they cannot be broken down using the chemical reactions. I have already told you that this, you can say, this can be the introduction of elements, this can be the definition of elements. Here we start with that. If you want to make it clear, that an element is substance that has, that contains one types, atoms of only one type. Elements are chemically the simplest, okay, the simplest substances, so they cannot be broken down using which thing? Chemical reaction. You cannot break down by using the chemical reactions, okay. For example, neon, this is an example. Neon is and its example, okay. You can say this is the definition. If someone asks what is the element, you will say the elements are made up of the same type of elements which cannot be decomposed by simple chemical methods, because it contains only neon atoms, okay, which have the symbol neon. It cannot be broken down into atoms of any other elements. Means if you break it down, first it's not difficult to break, it's not easy to break it. But if you break it, so new element will not be formed, subatomic particles will be formed, okay. Means atom, if you break an atom, it's not easy. It's not easy by simple chemical methods. It needs a lot of apparatus and a lot of energy to form the cathode, anode, to form the cations, anions, okay. So but if you become successful to break it, okay, by extraordinary chemical methods, not simple chemical methods, then you will get electrons, protons, and neutrons, okay. So water is not an element. Water is not an element, okay, because it can be broken down into the elements of hydrogen and oxygen. Now let me make it here H2O. This is the formula of water, and you understand it that hydrogen, it has two atoms of hydrogen and one atom of oxygen, okay. When it breaks down, it will form hydrogen in its molecular form and oxygen in its molecular form too. Means you cannot make it in atomic form. It's not balanced. You can say it's not balanced because here are two oxygens, but there is only one oxygen. To make it balanced, so we change the coefficients. We write here 2. Are you understanding? So now we have balanced the oxygen, but the hydrogen is not balanced. So to make it balanced, we write here 2. Mostly you observe such type of equations for water, that when it breaks down into its hydrogen and oxygen element. Now it is element. Hydrogen is separate element because 2 multiply 2, 4. 4 atoms, there are atoms of only hydrogen. 1, here is 1. If we don't write, so here is the 1, okay. But I think we don't need to write, okay. Just I am telling you. So I am going to erase it, that's why, because we don't need to write it. Okay. So here we are, sorry, here we are once again, oxygen 2, it's good, okay. So here is 1, we don't need to write it, and we mostly don't write. What I want to tell you over here, that if you see what is the water, this 2 shows its number of moles. This is called coefficients. These are called coefficients. You will see when we study about balancing, then you will see what are the coefficients. What are the coefficients? Okay, but now leave it. Okay, now you just observe here that H2O means this is the formula of water. So H2, it has 2 atoms of hydrogen and 1 of oxygen. So it cannot be element because it has 2 different types of atoms, 2 of hydrogen and 1 of oxygen. So here is the atoms combined with each other to form a molecule, and this molecule is known as the water. Is it okay? Next we are going to study that these are the elements. These are the elements. Okay. Water is not an element because it can be broken down into its elements. Okay. Now you cannot break this element and this element into further elements. Okay. You cannot make from hydrogen to oxygen to hydrogen, or from hydrogen to nitrogen, or any other element. Okay. So it's clear from here that these are the elements and that is the molecule. So it's not an element. Okay. So next we are here. This way of descending an element is sufficient for this page of your studies, but more details will be required as you progress through this course. Means you will be needed more details for the elements. Okay. For example, some elements contain isotopes. This is the term which we are studying now. Okay. So we will need isotopes. What are the isotopes? Isotopes. What are the isotopes? Isotopes means same atomic, the elements which have the same atomic number but different atomic masses, or you can say nuclear numbers. Okay. Do you understand what is atomic number? The number of protons. What atomic mass is proton plus a neutron? So this is atomic mass. Only when we talk about the protons, so this is the atomic numbers. So here are example: neon. It has 10 protons. It's okay. Second, neon. It also has 10 protons. Neon, 10 protons. So it has 20 atomic mass. It has 21 atomic mass. It has 22 atomic mass. So if they have the same number of protons, so which thing differs due to which the isotopes are formed? Actually, it is due to the different number of neutrons. Do you understand now? Mass is the proton plus a neutron. So here you see that proton are 10 in this case, in that case 10, in that case 10. But which thing is differing? 10 plus 10, 20, 10 plus 11, 21, 10 plus 12, 22. Means here are, so it is actually, you can say all isotopes of the same element have the same number of protons and electrons but different number of neutrons. Okay. So this is another definition. This is second definition. You can say that what are isotopes? They have same number of protons and electrons. Always remember that protons and electrons are always equal. Okay, because they have positive charge and they have negative charge. So in this way atom is neutral. So to have atom, that we call it neutral, so it has equal number of protons and neutrons. So what is different? Neutrons. Okay. Okay, let's move to the next. It's taking a little bit of time. What's an atom? What is an atom? I explain it by a simple example. Have you seen full stop over here? Any full stop? This is bigger than full stop, but you consider it full stop. This full stop contains 20 lakh. How many? 20 lakh atoms. The lakh atoms. Is it clear? So I studied in I read it in one of the books that one full stop contains 20 lakh atoms. So you can say that atom is a part of element, but it is too small. But still it can take part the in the chemical reactions. Smallest particle of an element which can take part in a chemical reaction. Okay, if we go down the atoms, if we break the atoms into electrons, protons and neutrons, then that will not be taking part in chemical reaction. Okay, so here we read it, we make it clear. Okay, you already know that what an atom is, because we have used the terms to help you understand what an element is. Okay, you have studied that what an element is, made up of some type of atoms which cannot be decomposed by simpler chemical methods. Atoms are far too small. What we call it? Far too small to be seen with the human eye. Actually, atom is Greek word. It derived from atomos. There was a scientist whose name was John Dalton. So he discovered atom, and he said that atom, it means indivisible. Indivisible means it cannot be divided further. So you can understand. But later some scientists came and they divided atom into subatomic particles, which are known electrons, protons and neutrons. But at that time it was given the name of atom, so it is still atom. It meant and it means that it is indivisible. But it could be divided, and we study nowadays electrons, protons and neutrons. We can understand when we study the structure of atom that there are electrons, protons and neutrons. But here we are, that help you understand what an element is. Means element is made up of same type of atoms. So we used atoms to understand the element. What atom is? Atoms are far too small to be seen with the human eye. You can't see with the human eye. You can see a tiny grain of sand, and this contains many billions of atoms of silicon and oxygen. Billions of atoms of silicon and oxygen. I told you less. Tiny grain of, this is not tiny. Actually with this digital pen I can show you just this much. Okay, I can't show you smaller than this. Okay, so tiny particle of sand. What's the formula of sand? Silicon dioxide, SiO2, or it is also called silica. Okay, so this silicon dioxide or silica, okay, so it has silicon and oxygen, so both are in atomic ratio 1:2, means 1 of silicon and 2 of oxygen combined to form the sand. So if we take a tiny grain of sand, and this contains many billions of atoms of silicon and oxygen, billions of, billion Arab ko kehte hain, means it's bigger than millions. I told you 2 million in full stop. Okay, so that could be the previous research, but now this is the updated version. This is the updated. Okay, an atom can be described as the smallest part of an element that has the properties of an element. Okay, is it clear? The atom can be described as, if you want to describe atom, so you will say that an atom can be described as the smallest part of an element that has the properties of that element. Is it okay? This meaning is fine when you work with the topic 1. However, in topic 2, you will need to recall the atom contains even smaller particles called electrons, protons, neutrons. We will be studying over there, okay? Even smaller particles, which you have not studied in this book yet. Okay, so these are called subatomic particles. What do we call it? Subatomic particles. Is it okay? So sub means smaller, the smaller particles of atoms. Okay, what is a molecule? Molecule, what is a molecule? I tell you. Atoms combine to form molecule. Atoms combine to form molecule. Okay, so now we are going to read it, that what is a molecule. This is easier now that we know the meaning of atom, element and atom. Means atom is the smallest particle which has the properties of elements, and element is made up of the atoms. Okay, same type of atoms, and which can take part, which cannot be decomposed by simpler ways. Okay, so you could describe a molecule as a particle made up of two or more atoms bonded together. So this is the definition which I have already told you. Made up of two or more atoms bonded together. What is its example? Hydrogen is a molecule. It has two atoms of hydrogen. Okay. Oxygen is a molecule. Is it okay? So, if a molecule contains atom of the same element, then result is the molecule of an element. Molecule of an element. We can also call it homoatomic molecule. Homoatomic molecule. You can ask me, sir, what is homo? Do you know? Homo, as we say, home. So in your home, only same type of the members can live. If there come any guest, then you will take him to the any other room, separate room. Okay. So homo means same family, as we say home, same family, the place where the one family lives. Okay. So homo means same type, same nature. The atoms of same nature means chlorine. This is molecule because it is made up of two atoms combined. Okay, it could be more than two atoms. Suppose ozone we have studied in the O levels, if you remember. So it is of three atoms. Okay, so these are homoatomic. For example, a molecule that contains two atoms of hydrogen joined together can be represented by H2, as I already told you. This formula contains only one symbol H, so it is the formula of an element. This is the formula of an element. Okay. If a molecule contains atoms of two different or more different atoms, then the result is a molecule of a compound. Molecule of a compound. What is compound? This is molecule of a compound. This is simple molecule. Molecule of atom. You have studied molecule of atom. Okay, and this is the molecule of a compound. It can also be called heteroatomic molecule. It's molecule heteroatomic. I'm telling you something which are extra. You might know it, but you need to know it now. Okay, heteroatomic molecule. It will develop itself. I wrote E, but it's a bit slow. Okay, so heteroatomic molecule. For example, a molecule that contains two atoms of hydrogen and one of oxygen joined together to be represented by the formula of H2O. Okay, so this formula contains two different symbols. So you can say formula of a compound water. So water is a compound. Water is a compound. Its formula is H2O. Okay. Next we are going to study what is a compound. Molecule of a compound, molecule of an element. You have studied it, okay? And what is a compound? This is not a molecule of a compound. This is simple compound. Now we can describe compounds. This is substance containing atoms of different element combined together. That's okay. If atoms are, what is compound? What is compound? You understand it. What is compound? If it contains atoms of different elements. Okay. Note that some compounds contain large number of atoms bonded together. For example, H2SO4, sulfuric acid, calcium carbonate, CaCO3, calcium carbonate. Okay. But other compounds contain molecule with only. Okay, welcome back. So it has started again. What is an ion? What is an ion? Okay. So you have studied it before that ions any species which has any charge. A species which has any charge. It can be atom or group of atoms. Okay. One way to describe an ion is a species consisting of one or more atoms joined together and having positive or negative charge. Suppose we say Na. Okay, sorry. We have